So for this video, we're going to be using partial fraction decomposition with this number 15 in chapter 6.4. And so the first thing we'll do is we'll check to make sure that the numerator has a smaller power than the denominator, and since this is a 2 and this is a 3, we're alright. If the numerator was greater than or equal to the bottom power, we'd have to do long division and just more steps, but we're good here. So we'll rewrite this as negative x squared minus 22x minus 50 over, and we're going to want to factor that out. That'll factor out into x times x plus 5 squared. And now, since that's repeating, we're going to want to make that an x in the first denominator plus an x plus 5 in the next one. And since it's repeating, we're going to make it x plus 5 squared. And then on top, we just need some constants, so we'll just use a, b, and c. Now what we want to do is we're going to multiply each by the least common denominator, so that's going to be x times x plus 5 squared, all this, times x plus 5 squared. Now what we have left on this side is negative x squared minus 22x minus 50. That'll be equal to a times x plus 5 squared, because the x's will cancel, plus b x times x plus 5, because only one x plus 5 cancels, plus cx, because the x plus 5 squares cancel. And now we're going to want to multiply that out on that side, so we're going to have negative x squared minus 22x minus 50 again is equal to ax squared plus 10ax plus 25a. Just multiply that out. Now plus bx squared plus 5b, that's a bad b, I'm sorry, b plus cx. Okay, now that we have all that, we can look at our terms. Here we have negative 1x squared, so we'll take negative 1 and we'll make the coefficients equal. So negative 1 equals a, because that's a square, ax squared, and plus b, that's bx squared, plus 0c, because we don't have a cx squared, we want c in there anyway. And then for the next one, we'll use negative 22x. So negative 22 equals all the x terms, so 10a, look at that. This should be 5bx here, sorry about that. Plus 5b, get rid of that then, plus c. And then for our last one, we'll have negative 50 equals the constants, which is just 25a. And we'll just make that plus 0b plus 0c. And now you could do one of two things. You could use inverse matrix, which I prefer, or you can use an augmented matrix to find the reduced row echelon form through Gauss-Jordan elimination, but to me that's just a waste of time. So I'm going to make coefficient matrix, so 1, 1, 0, 10, 5, 1, 25, 0, 0. I'm going to take the inverse of that and multiply that by the answers matrix, negative 1, negative 22, and negative 50 equals, going to get a 3 by 3. And so we go to our handy dandy calculator, turn it on first, then second matrix, edit, oops, 3 by 3, 1, 1, 0, 10, 5, 1, 25, 0, 0. Okay, then go to matrix number 2. Edit, 3 by 1, negative 1, negative 22, negative 50. Quit that. Matrix A, inverse times matrix B, enter. You have negative 2, 1, and negative 7. That just means A equals negative 2, B equals 1, C equals negative 7. And so for the answer, we're going to, for the answer, negative x squared minus 22x minus 50 over x cubed plus 10x squared plus 25x. That's going to equal negative 2 over x plus 1 over x plus 5 plus minus 7 over x plus 5 quantities squared. And that is how we perform partial fraction decomposition in 6.4.